Hello and welcome to today's class. In today's class, I'm going to handle completing square method as a way of solving quadratic equations. So if you've been following our classes, then you realize that in the previous video, we discussed completing square method and we gave a general format for all quadratic expressions and expressions that actually meet criteria to be called perfect squares. And so we said that whenever you have a quadratic equation, ax squared plus bx plus c, all right, that for it to be a quadratic, for it to be a perfect quadratic, a perfect square quadratic equation or expression, then a, first of all, must be equal to 1. That is 1. A, first of all, must be equal to 1. And c, all right, and c should be b all over 2 b divided by 2 squared. So this is the criteria that we gave that qualifies a quadratic equation expression to be a perfect square. And so we said that in a perfect scenario, then we would have x plus bx, all right, plus b all over 2 squared. So basically, what we've done here is we've rewritten c using b all over 2 squared. And so we also said that if this then is the case, then we can also find its square root, all right? But before we find the square root, maybe we want to write this particular expression in a factorized form. So when you write this in a factorized form, note we are going to have x, write it in terms of x and the value of c, that is b there. So it's going to be x plus b all over 2 squared. So basically, this here expression on the left hand side can be factorized, and this is what we'd end up having. So with this here, it's easy to then get the square root, because the square root will always be then in this case x plus b all over 2. All right, so when you find the square root of x plus b all over 2 squared, then this is what becomes our square root. So we are going to use this concept, knowledge of how to complete squares of quadratic expressions and equations, to actually solve actual equations. And so let's handle our first example in this. Awesome. So for our first example, we have a quadratic equation, x squared plus 3x minus 54 equals to 0. And we are going to attempt to solve this problem using completing square method. All right. So how would we approach this? So we are going to write it such that it's an incomplete quadratic expression by taking the value of c here on the right hand side first. So we're going to have it as x squared plus 3x being equal to, when you take negative 54 to the right hand side, it becomes 54. Now we have a situation where we can then rewrite this equation as a perfect square. So after we've done this, basically, we are going to then give our approximate value of c as b all over 2 squared. And whatever we do on the left hand side, we are going to do on the right hand side, plus b all over 2 squared. All right, remember this here is the same format that we were using to complete, to identify perfect squares, perfect squares of quadratic equations and expressions. So looking at this equation here on the left hand side, we can already tell the value of b. The value of b will be 3. So basically we're going to write it, we're going to include it in this whole equation wherever we see b. So wherever we see b, we're going to put 3. All right, so it's going to be x squared plus 3x plus 3 all over 2 squared equals to 54 plus 3 all over 2 squared. I hope you're following. Now, with this here, it then becomes easy to solve the rest of the equation, because we can also then find the factorized value of whatever we have in the left hand side. We have x squared plus 3x plus 3 all over 2 and that is squared. So for us to write the factor's value of the left-hand side equation, remember we're going to take x, okay, plus b all over 2, which is going to be 3 all over 2 in this case, okay, plus 3 all over 2. All right, and all of that is going to be 3 all over 2 square, plus 3 all over 2 without the square, and all of that is going to be squared. And then we are going, basically that's what we're going to do on the left hand side. We are going to write it in its factorized form, and the factorized form basically is, as you can see, all right, and that is 3 all over 2 all over that, all over 2, and all of that going to be squared. And so we are then going to try and simplify the right hand side. Okay, so we are having 54 plus 3. Let me get my calculator. So we're having 54 plus 3 all over 2. Okay, and all that is squared. So when you do your calculation, right, you are supposed to get 225 all over 225 all over 4. All right, so that is what we're going to get on the right hand side if you actually add that. If you add 54 to 3 all over 2 squared. So then we are then going to try and find the square root of the left hand side and the right hand side. Okay, so you find the square root of the whatever you have, everything in the left hand side, and the square root of everything you have on the right hand side. So when you find the square root of everything you have on the left hand side and you have everything you have on the right hand side, note you're going to remain with x plus 3 all over 2 equals to 225 divided by the square root of 225 divided by 4. Note that will be okay. All right. Yeah, sorry for the delay. So anyway, the square root of 225 all over 4 will actually be 15 all over 2. And then you can always find the value, and this is going to be positive or negative. Remember, when we talk of square roots, we can always have them as positive or negative, so that when you have 15 over, when you have, like, let's say, when you talk of 4 as a square, its square root will be positive or negative 2. That means that if you take 2 times 2, you get 4, and you take negative 2 times negative 2, you still get 4. So that is basically what you're doing here. So for us to find the roots of this particular problem, then we are going to make x a subject of the formula here, and so we're going to take 3 all over 2 on the other side, and that will be negative 3 all over 2 plus or minus 15 all over 2 plus or minus 15 all over 2. So remember, when you're finding roots, we find them as a pair, all right? Because we're dealing with quadratic equations, we find them as a pair. So the roots can be repeated, and sometimes they're unique, all right? So in this particular case, I believe they're unique. So we're going to find 2 values of x. So we're going to find the value of the first value of x by adding, by treating the root of 15 all over 2 as a positive, and then the second value will treat the root of 15 all over 2 as negative. So basically for x1, let me draw this line here. For x1, we will have negative 3 all over 2 plus 15 all over 2, all right? And for x2, we will have negative 3 all over 2 minus 15 all over 2. So basically that's what plus or minus mean here, right? So for the first value, we'll take a positive. We'll treat 15 over 2 as a positive, and for the second value, we'll treat 15 all over 2 as a negative. So when you do your math, then you'll find that the value of x in x1 here is equal to, awesome. So when you do your math here, negative 3 all over 2 plus 15 all over 2, then you get that this is equal to 6. So x1 in that particular case will be equal, the first root will be equal to 6. And for value of x2, you will notice that this here will give you negative 9. So there it is. The first value of x is 6, and x2 is actually negative 9. So this is how we use completing square method to solve these problems. On to the next one. Let's try and handle the second example and see exactly what you may be missing or what you may have not noticed in the first example. Okay, so on to example 2. So we are having x squared plus 8x plus 9 equals to 0, and we are basically supposed to solve this quadratic equation using completing square method. All right, so we're going to rewrite it in a format that will allow us to make the left hand side a perfect square. So basically that means for us we're going to have x squared plus 8x, and then we're going to take 9 to the right hand side. All right, so when you take 9 to the right hand side, we're going to then have negative 9. All right, then for us to make the left hand side expression a perfect square, we will then add b all over 2 squared to the left hand side, and whatever we do to the left hand side we do to the right hand side. So we'll also have b all over 2 squared to the right hand side. Awesome. So at this juncture it then becomes easy to rewrite the whole equation using the value of b. So we can already identify that the value of b here will be what? 8. So we're going to have it as x squared plus 8x plus 8 all over 2, all right, squared equals to negative 9 plus 8 all over 2 squared. So wherever we had b, I've just written the value of I've written 8 as its value. Of course, then from this particular juncture, it becomes easy to then find the square, refactorize whatever we have in the left-hand side, write it in terms of its factorized version, as you also simplify what we have on the right-hand side. So basically, to find the factorized version of this particular problem, we are basically going to take x here, all right, plus 8 all over 2, which we already know is 4, okay? 8 all over 2, we already know is 4. So we just want to have it as 8x plus whatever we have in the bracket, and that is going to be 4. And all of that is going to be squared, all right? And so the right-hand side we'll get, we have negative 9, okay, plus 4 squared. And this basically will give us 7. So negative 9 plus 8 all over 2, which is 4, and then you square that, and that will give us 7. All right, so for us to find the value of x, all right, for us to find the value of x, notice that we are going to then find the square root of what we have in the left hand side and what we have in the right hand side. All right, so we're going to find the square root of this and the square root of that, and so the square root of x plus 4 squared will basically be x plus 4. All right, and so that will be equal. Now the square root of 7 will actually be a recurring decimal. So we will instead opt for writing it as plus or minus root 7, so that we do not really give room for much error, all right? Because in this particular case, 7 also happens to be as negative, root 7 also happens to be a sad. All right, so for us to find the value of x1, all right, so x1, we will have it given by, but let us not go straight to x1. Let us just first of all make x the subject to the formula so that it's then easier. So for us to find the value of x, we are going to then have positive 4 taken to the right hand side, and so that's going to be negative 4 plus or minus root 7. So for x1, we will treat the root of 7 as a positive. So basically it will be negative 4 plus, all right, plus root 7. And for x2, we will have it as negative 4 minus root 7. So basically these two are going to be our solutions. So you can have it as x1 being equal to negative 4. If you want to simplify further from here, you can do it on your own, and x2 will just be negative 4 minus root 7. So that is it for the second example. And so I'm going to handle the last example where we are having the value of a not being 1, so that you see how we actually deal with such situations. Awesome. So on to the third example and the last example of this particular class. So we are having a situation where a actually ain't 1. We're having a as being 2. So we have 2x minus 22x plus 60 equals to 0. And we are supposed to solve this particular problem using completing square method. And remember the conditions for us to actually write a perfect square of quadratic equations or expressions. A must always be equal to 1. So for us to then start solving this problem, basically, we're going to have to divide everything here, every term in this equation by 2, so that we have our a here being equal to 1. So when we divide all of these terms by 2, we will have x squared minus negative 11x plus 30 being equal to 0. So that is the first thing that we've done. We've actually made sure that a is first equal to 1, all right, by dividing all of these terms by the coefficient of a, which happened to be 2. So that 2 divided by 2 giving us 1, negative 22 divided by 2 giving us negative 11, and 60 divided by 2 giving us 30 there. Of course, 0 divided by any number then becomes 0. Then we are going to write it in a format that then allows us to write it in terms of completing square as a perfect square. Sorry. So basically that's going to be x minus 11x, and so we're going to take 30 on the right hand side, and when you do that it's going to be negative 30. All right, so for us to make the left hand side a perfect square, we are going to have c being equal to b all over 2 squared, and whatever you do to the left hand side we do to the right hand side, so b all over 2 squared. Awesome. All right, so we look at our expression here, and we can already tell what the value of b will be. So the value of b will be negative 11, as that is the coefficient of x. So we will rewrite the whole expression and have negative 11 in place of b. So that's going to be x squared minus 11x plus negative 11. All right, because the value of b actually happens to be negative 11 all over 2 x being equal to negative 30 plus negative 11 all over 2 squared. All right, so this is done. So what we do next after this is basically write the left hand side in its factorized form. All right, so we factorize whatever we have on the left hand side, and so when we factorize whatever we have in the left hand side, I told you earlier that we're going to check the value of x and whatever we have in the bracket. So it's going to be x minus 11 all over 2, all of that squared, and that will be equal to 30. Okay, so we're supposed to that negative 30 plus negative 11 all over 2, and all that is actually squared. So when you simplify this, we are going to get this as being equal to a quarter. All right, as being equal to a quarter. Then note, for us to find the value of x, we'll find the square root of the left hand side and the right hand side. So the square root of the left hand side is square root of the right hand side, and that's going to be x minus 11 all over 2, all right, being the square root of the left hand side, and the square root of the right hand side is going to be 1 all over a half, basically. All right, so for us to find the value of 2, all right, for us to find the value of x, then we are going to basically make x subject to the formula here. And so it's going to be that x is equal to, when you take negative 11 over 2 on the right hand side, it's going to be 11 all over 2. All right, so this should have been plus or minus. All right, sorry, the square root should always be a plus or minus. That's going to be 11 over 2 plus or minus a half. Okay, plus or minus a half, so that when you take, it evens out. All right, so for x1, we're going to have half as positive. For x2, we're going to have it as negative. All right, so x1 here, we're going to have it as 11 all over 2 plus a half plus a half. And for x2, we are going to have it as 11 all over 2 minus a half. So when you do your math, then you're going to find the values as follows. Oh, sorry for the delay. So anyways, when you take your values, when you find your values for this value, for this sample question, then you're going to find that this will be equal to 6 and this will actually be equal to 5. Yeah, so the roots of these particular equations, a particular equation are 6 and x2 happens to be 5. So that is it for this particular class. It's been a wonderful time. We've spent learning how to solve quadratic equations using completing square method. And if you have any question, drop a comment in the kind of write it in the comment section, and I'll get back to you as soon as I can. Thank you and have a lovely day.